Okay, so next type of friction, it is the ladder friction. So note down the first problem on the ladder friction. So here one ladder AB is resting against the vertical wall at the point A and on the horizontal floor at the point B. The coefficient of static friction at both the contact surfaces 0.25, and one person is climbing up the ladder, that is the person ascend the ladder. Ascend means it is a climbing up. So the condition given is that person having the weight 600 Newton and he tries to ascend the ladder without causing the ladder to slip. So this is the equilibrium condition. So we have to find out how much distance that person can ascend up the ladder without causing ladder to slip. So just imagine that person is somewhere here and he tries to ascend the ladder. So the person is having the weight 600. Ladder itself has its own weight, which is a 1000 Newton. So this weight will act from the center of gravity. So just imagine this is the center of gravity. So this is the CG. So weight will always act in the downward direction. So this is 1000 Newton. Okay. Now just imagine if the ladder starts to slip, then it will have the position after its rotation like this. It will change this angle 60 degree. So it will take this position after some time. Okay. As this angle 60 degree, it will change in the second position. That means the ladder will rotate about this point. Okay. So this motion is a rotation. And therefore, when we solve the problem on the ladder friction, we will use three conditions. One is summation of moment 0, because ladder has a tendency to rotate about this point or about this point as there is a change in angle. Second condition, summation fx 0, and third condition is summation fy 0. So these three conditions we can apply when we solve the problems on the ladder friction. So to solve this problem, your first step is free body diagram. So the ladder is AB. So A and B, these are two contact points with the wall and with the ground. Now this ladder, it is having the self weight, which is equal to 1000 Newton. So this is the center of gravity. So weight acts in the downward direction, vertically downward. So it is a 1000. This point is G. So distance B to G. So total ladder, it is having the length 5 meter, which is given in the problem. So this will be 2.5 meter. It is a half distance. Next, the person is standing on the ladder at some distance. So we will assume this distance for the limiting condition. So this distance is x. So if the person crosses this distance x, then ladder will start slipping. So this is the limiting distance. So just imagine the person is here. So we have to consider the weight of that person. So this is the weight, and this is equal to 600 Newton. Let us take this point as a point P, and this distance, we are considering the distance along the plane, sorry, along the ladder. So this is equal to x with respect to point B. Now next we have to consider the normal reaction. So there is one contact with the ground. So it is the B contact. So there will be normal reaction like this. So this is normal reaction NB. It is perpendicular to this horizontal plane. So here we will have the normal reaction. So NB is exactly vertical. Next, at the point A, the vertical wall will offer the normal reaction on the ladder. So it is the NA. So NA is exactly horizontal at the point A. So here we have shown all the forces. Now we have to observe the impending motion. Just imagine ladder starts slipping. So as the ladder slips, the point B, it will have the tendency to slide in this direction. At the same time, the point A, it will slide in this direction. It is vertically downward and it is on the right side. So this is the impending motion. So for the point B, we will show the impending motion like this. And for the point A, its impending motion is in the downward direction. Now show the friction force. So friction force at the point B will be exactly opposite to the impending motion. So this is the friction force. And this value is 0.25 coefficient of friction. Normal reaction is NP. Now this impending motion is in the downward direction. So friction force would be exactly upward. So this value is 0.25 into normal reaction NA. So we have shown all the forces. Now next we have to find out that distance x. So for that we can use the condition of equilibrium, which is summation fx0, summation fy0, and summation of moment 0. So use summation fx is equal to 0. So for the summation fx, first is Na, then we have 0.25 Nb, so minus 0.25 Nb, this is equal to 0. So only two forces in the x direction. Then use summation fy0. So for the fy, this is 0.25 Na, then this is minus 1000, then this is minus 600 and plus Nb. So from this equation you can write 0.25 Na plus Nb, this is equal to 1600 Newton. So take this equation 1, this is equation 2. Solve these two equations simultaneously. So you will get the answer for Na. So Na is equal to 164.71 Newton. Nb reaction so it is 658.84 Newton. Now use third condition, which is the summation of moment. Finally, we have to find out the distance x. So summation of moment by all the forces. Now we have to decide the moment point. So as we have taken the distance x with respect to point B, so take the moment about the point B, and this is equal to 0. So here we have to take the moment by all the forces about the point B. So starting from NA. So for the NA, when we take the moment by NA, we need to find out its perpendicular distance. So that distance is not given in the problem. So we can construct the right angle triangle. So you can make one construction. Just draw one horizontal line like this. Draw a vertical line. So take this point as a M. So triangle AMB is the right angle triangle. So this distance, that is the AM, is the perpendicular distance for NA. So moment will be NA into distance AB, and this moment, it will be a clockwise moment about the point B. So it is a negative. Next, we have this point 25 NA. So for the point 25 NA, this is the line of action, and this is the perpendicular distance, that is the distance MB. So moment will be 0.25 into NA and distance MB. This is the perpendicular distance. This moment, it is also clockwise about the point B. So it is negative. Next, we have this 1600 Newton. So for the 1600 Newton, just extend this line of action. So this is perpendicular. So you will get another triangle. So in this triangle, for 1600, this is the perpendicular distance. So this distance we can find out. So this is 60 degree. G to B is 2.5 meter. So you will have this triangle. This is G, this is point B, and this is the line of action for that. Sorry, it is 1000, not 1600, 1000 Newton. So this distance, this is 60, this is 2.5. So it is adjacent, so it is a 2.5 cos 60. So you will take the moment 1000 into 2.5 cos 60. This is the perpendicular distance. This moment is anti-clockwise, so it is positive. Next, we have this 600 Newton. So again, for 600 Newton, this is the line of action, and this is the perpendicular distance. So you can consider the small right angle triangle. So this is the point P, this is point B. Distance PB is a x, and this is the line of action, force, and this is perpendicular distance. So this distance is x, this is 60 degree, so x cos 60. So your moment will be 600 into x cos 60, and it is also anti-clockwise, so it is positive. And this is equal to 0. Moment by NB, moment by this 0.25 NB, it will be 0 because two forces, they are passing from the moment point. So there is no perpendicular distance, and that's why moment is 0. Now put the value of this distance AB and distance MB. So for that, consider the total right angle triangle AMB. So in that triangle AMB, so this distance, so this is M, this is B. Total is 5 meter. This is 60. So this is 5 cos 60, and this is 5 sin 60. So put this value in this equation and get the value of distance x. NA we have already calculated. Put this value in this equation, and then you will get the x value. So check this answer. You try to solve that equation and check whether you get the same answer, 2.304 meter. That means the person, it can ascend the ladder by x distance, which is equal to 2.304. If he crosses this distance, then ladder will start slipping. Up to this distance, ladder will be in the equilibrium. There is no sliding motion.